In this part of numbers, we are going to see the problems of factorization, that is how to determine the number of factors of a particular number. Also, we are going to look at the power cycle concept, means any number raised to any other number, what will appear in the unit digit. And also, we are going to see the problem of finding largest power of any number in any factorial. So let us proceed. Let us start with factorization. Let us take a number n. Let us factorize this number n as a product of prime factors as a to the power of p into b to the power of q into c to the power of r, where a, b and c are the prime numbers. Then how to determine the number of factors or count of factors of this number n? It can be found as p plus 1 into q plus 1 into r plus 1. Let us understand this with a simple example. Suppose I take a number, say 90, and if I ask you what are the different factors of the number 90, you can count and tell me, and you can list it also. We have to consider all those numbers starting from 1 up to 90 which can divide 90. And those factors are 1, 2, 3, 5, 6, 9, 10, 15, 18, 30, 45 and 90. Okay, so these are all factors of 90. ये सारे numbers 90 को divide कर सकते हैं, giving 0 as a remainder. Well, here you can count the number of factors listed. There are total 12 factors for the number 90. Now, how to apply this formula what we have seen here? For this, we need to factorize the number 90 like this. So 90 can be written as 9 into 10 at first. So this 9 can be written as 3 square and 10 can be written as 2 into 5. So it is 2 into 3 square into 5. This is how I can factorize the number 90, where 2, 3 and 5 are the prime numbers. So I have factorized the number 90 in the form of a to the power of p into b to the power of q into c to the power of r. So the number of factors of 90 will be equal to p plus 1, that is 1 plus 1, into q plus 1, that is 2 plus 1, into again 1 plus 1. So it is like this, which will come out to be 12. So this is how we can determine the count of number of factors of a particular number. Let's take a number 360. If I ask you how many factors are there for the number 360, by the same procedure we have to determine. So the number 360 can be factorized as a product of 36 and 10 at first. Now 36 can be further written as 4 into 9 and 10 can be splitted as 2 into 5. So we will collect all 2's, all 3's, all 5's and we can write it as 2 cube into 3 square into 5 to the power of 1. Now 2, 3, 5 are prime numbers. So the number of factors of 360 will be equal to 3 plus 1 into 2 plus 1 into 1 plus 1, which will be equal to 24 factors. So there are total 24 factors of 360 which can divide 360, giving you 0 as the remainder. So my next question is now, in how many ways can the number 360 be expressed as a product of two factors? जैसे कि सबसे पहला पेयर 1 into 360, दूसरा पेयर 2 into 180, तीसरा पेयर 3 into 120 and so on. So ऐसे कितने पेयर्स बन सकते हैं in which the number 360 can be expressed as a product of two factors? This is very simple. This is equal to number of factors divided by 2. Factors का आधा हो जाएगा. So that is equal to 12. My next question is the number 360 a perfect square? Well, the clear cut answer for this question is no. 360 is not a perfect square. उसका square root एक integer नहीं रहेगा. So my next question is, what is the smallest number that should be multiplied with 360 to make it a perfect square? Well, for this we have to factorize the number 360 like this. 2 cube into 3 square into 5. Now, to make the number perfect square, we should have the powers as even. So यहाँ पर 2 cube है, so we cannot divide it into 2 equal halves. So there is a need of 1 2 here. So it will be 2 to the power of 4. Well, Here it is 3 square, so we can divide it into 2 equal half to find its square root. And 5 is one single, so there is a need of 1 5 here. Okay, so if I multiply the number 360 with 1 2 and 1 5, that is 10, it will become 3600, जिसका square root as an integer निकाल सकते हैं. So 3600 is a perfect square. So the smallest number with which I should multiply 360 to make it a perfect square is 10. So my next question is, the smallest number which should be multiplied with 360 to make it a perfect cube will be what? By the same procedure we have to give the answer, that is, we need to first factorize it. So if the number has to be a perfect cube, the power of every prime number should be a multiple of 3, because here we should be able to trifurcate the number. Okay, so यहाँ पर 2 का count 3 है, so no issue. 3s are only 2, so there is a need of 1 3 here. Okay, and 5 is one single, so there is a need of 2 5s here. So the smallest number with which I should multiply 360 to make it a perfect cube is 3 into 5 square, that is 75. So with the help of factorization like this, you can even determine the square root or cube root of any 3-digit, 4-digit, 5-digit number without using a calculator. Let us understand problem number 1. How many numbers are there between 1 to 5880 which can divide 5880 leaving a remainder as 0? So here we need to determine the count of factors of 5880. So 5880 seems to be an even number, so obviously divisible by 2. The last 2 digits 80 are divisible by 4, and if we consider the last 3 digits, they seem to be divisible by 8. So we can divide the number 5880 with 8. So we get 8 into 735. Now if we take the sum of the digits of 735, that is 15, it means 735 is a multiple of 3. So I can write as 8 into 3 into 245. Now we can divide the number 245 with 5. So we can further write as 8 into 3 into 5 into 49. 49 is a 7 square. So the number finally gets factorized as 2 cube into 3 to the power of 1 into 5 to the power of 1 into 7 square. Now 2, 3, 5, 7 are all prime numbers. So the number of factors of 5880 will be equal to 3 plus 1 into 1 plus 1 into 1 plus 1 into 2 plus 1, which comes out to be 48. Now in the question it is asked, how many numbers are there between 1 and 5880? So if we exclude 1 and 5880, these two factors, the remaining factors are 46. Hence option A is a right answer. Let us understand the concept of power cycle. Let us say there is a question which is asking you what will appear in the unit place of 2 to the power of 27. We know that 2 raised to the power of 27 will be a very big number. But here in this particular number, you have to only guess what will appear in the unit digit. Okay. So इसके लिए अपन 2 का powers चालू करते हैं as 2 to the power of 1. So 2 will appear. If I take 2 square, it will be 4. If I take 2 cube, it is 8. 2 to the power of 4, it will be 16, 32, then 64, then 128, then 256, then 512, 1024, and so on. Now if you focus on the unit place, it is 2486 like this. Further, again it is 2486. आगे में भी 2486 ही रहेगा. So what we see, after every fourth power, the same unit digit repeat, and this is called power cycle. So if I take the number n as 2, so n to the power of 1, n square, n cube, and n to the power of 4, what will appear in the unit place is 2486. And after 6, again the cycle repeats and 2 will appear in the unit place. This is how it continues. Now coming to the actual question, जहां पूछा है what will appear in the unit place of 2 to the power of 27. So we can now guess as 2 to the power of 27 can be written as 2 to the power of 4k plus 3. So 27 is nothing but 24 plus 3, and 24 is a multiple of 4, because we know that the power cycle repeats after every fourth power. So चौथे पावर के बाद 3 स्टेप्स आपको आगे जाना है. So that is 2, 4 and now comes 8. So 2 to the power of 27 के यूनिट प्लेस में आएगा 8. The same number 8 will appear if it is 12 to the power of 27 or 22 to the power of 27 or 32 to the power of 27 and so on. So यहाँ पर 2 के पीछे क्या है, whether it is 3, 2, 1 और भी कुछ रहे, इससे फर्क नहीं पड़ता. Unit digit is important here. Okay. So for 12 to the power of 27 or 22 to the power of 27 or even 32 to the power of 27 or anything, everywhere 8 will appear in the unit place. So जैसा अभी हमने 2 का पावर साइकिल समझा है, वैसे बचे हुए डिजिट्स के लिए भी समझ लेते हैं. For 2 we know it is 2486 2486 repeated infinitely. वैसे digit 3 के लिए it is 3971 3971 repeated infinitely. For the number 4 it is 4646, means 4 to the power of any odd number is 4 in the unit place and 4 to the power of any even number is 6 in the unit place. For the number 5, the unit place will be 5, whatever is the power of 5. For the number 6, the unit place will be always 6, whatever is the power of 6. For the number 7, the cycle is 9317 9317 repeated infinitely. For the number 8, it is 8426 8426 repeated infinitely. For the number 9, it is 9191, means 9 to the power of any odd number is 9 in the unit place and 9 to the power of any even number gives you always 1 in the unit place. So please remember this power cycle concept. It will be helpful to simplify problems based on this. Let us have a look at questions of power cycle. Problem 2. What will be the last digit of 463 raised to the power of 96? So यहाँ पर आपको क्या करना है? You only need to consider the power cycle of 3. So what is the power cycle of 3? It is 3971. Now the given number is raised to the power of 96 and 96 is divisible by 4. So we can write it as 463 to the power of 96 equal to 3 to the power of 4k. The unit digit is 3 and the power is 96, which is a multiple of 4. It means the cycle will stop at the 4th power. So what will appear in the unit place is 1. So the answer for this question is option D. Problem 3. What is the unit digit of 39 to the power of 11 minus 32 to the power of 11? Well, you can pause this video and try the question on the paper, and once you have solved it, you can again resume the video to look for the solution. Okay, now I will first consider the number 39 to the power of 11. So यहाँ पर unit digit है 9 और 9 का power cycle है 9191 like this. So we know that 9 to the power of any odd number will always give you 9 in the unit place. So 39 to the power of 11 के unit place में definitely 9 ही आएगा. Okay. Now considering the second number 32 to the power of 11 means I need to consider the power cycle of 2, and the number 2 can be written as 2 to the power of 4k plus 3, because it is 8 plus 3. I can write 11 क्यों लिख सकते हैं अपन 4k, that is 8 plus 3. So power cycle will stop at the third power. So 8 will appear in the unit place. So पहला जो नंबर है 39 to the power of 11 वो एक बड़ा सा नंबर होगा जिसके यूनिट प्लेस में 9 आएगा, और दूसरा जो नंबर है 32 to the power of 11 वो भी एक बड़ा सा नंबर होगा जिसके यूनिट प्लेस में 8 आएगा. So अगर सब्सट्रैक्शन होता है, दूसरा नंबर पहले नंबर से सब्सट्रैक्ट हो जाता है, it means 8 will get subtracted from 9 and you will get 1 in the unit place. Hence option A is a right answer. Problem number 4. What will be the unit place of 45 to the power of 8 plus 19 to the power of 11 minus 62 to the power of 18? अब ये तीनों नंबर का पावर साइकिल यूज करके वी विल डिटरमाइन द यूनिट प्लेस. सो पहला नंबर है 45 टू द पावर ऑफ 8. वी नो दैट 5 to the power of anything will always give you 5 in the unit place. So यहां पर 5 आ जाएगा. 9 to the power of 11, 9 to the power of any odd number will always give you 9 in the unit place. Okay, so दूसरे नंबर के यूनिट प्लेस में 9 आएगा. एंड द थर्ड नंबर इज 62 टू द पावर ऑफ 18. सो अगर पावर साइकिल ऑफ 2 कंसीडर करें so it is 2486 like this. So the number 2 is having a power of 18, means it is in the form of 2 to the power of 4k plus 2. So second power पे साइकिल रुक जाएगी एंड 4 विल अपीयर इन द यूनिट प्लेस. सो पहले नंबर के यूनिट प्लेस में 5 आएगा, दूसरे नंबर के यूनिट प्लेस पे 9 आएगा और तीसरे नंबर के यूनिट प्लेस पे 4 अपीयर होगा. सो इफ वी डू 5 प्लस 9 हियर minus 4 because first two numbers are added and the third number got subtracted, we get 0 in the unit place. Let us understand the concept of largest power in a factorial. सबसे पहले ये समझते हैं factorial होता क्या है. Factorial of a number n is defined as product of numbers from 1 to n. फॉर एग्जाम्पल अगर मैं नंबर 100 लू तो व्हाट इज विल बी 100 फैक्टोरियल. इट इज 1 मल्टीप्लाइड बाय 2 मल्टीप्लाइड बाय 3 मल्टीप्लाइड बाय 4 मल्टीप्लाइड बाय अप टू 100. दिस इज व्हाट 100 फैक्टोरियल मींस. नाउ द क्वेश्चन इज व्हाट इज द लार्जेस्ट पावर ऑफ 2 इन 100 फैक्टोरियल और हाउ मेनी 2s एग्जिस्ट इन 100 फैक्टोरियल. यानी 100 फैक्टोरियल में कितने 2s है दैट वी नीड टू फाइंड आउट. आई विल टेल यू द शॉर्टकट मेथड टू डिटरमाइन दिस. We have to successively divide the number 100 with 2 like this. So if I divide 100 with 2 successively, I get the quotient as 50, 25, 12, 6, 3, 1 and 0 like this. Here we are not interested in the remainder. We are only interested in the quotients that we get. Why we are dividing it by 2? Because we want to find out what is the largest power of 2 in 100 factorial. Hence we are dividing the number 100 with 2. Now we got this quotient. We need to take the total of this quotient from 50 onwards. So if we make a total of 50, 25, 12, 6, 3, 1 and 0, this total comes out to be 97. It means the largest power of 2 in 100 factorial is 97, or even 97 2s exist in 100 factorial. वैसे ही if I ask you what is the largest power of 3 in 100 factorial or how many 3s exist in 100 factorial, how you are going to determine. By the same procedure, you need to successively divide the number 100 with 3 like this. So पहले 100 को अगर आप 3 से डिवाइड करोगे तो क्वोशंट 33 आएगा. 33 को 3 से डिवाइड करोगे तो 11 मिलेगा. 11 को 3 से डिवाइड करोगे तो 3 मिलेगा, then 1 मिलेगा, then 0. Now let us take the total from 33 onwards of all these quotients. So that total comes out to be 48. It means there are 48 3s in 100 factorial. Okay. Now if I ask you how many 6 are there in 100 factorial or what is the count of 6 in 100 factorial, well, do not divide 100 with 6 because आपको जो भी नंबर का पावर लार्जेस्ट पावर निकालना है किसी भी फैक्टोरियल में, वो नंबर जरूरी है कि प्राइम होना चाहिए. 2 इज अ प्राइम नंबर, हेंस अपन 2 का लार्जेस्ट पावर निकाल पाए. 3 इज इवन अ प्राइम नंबर, इसलिए अपन 3 का लार्जेस्ट पावर एज 48 निकाल पाए. बट 6 इज नॉट अ प्राइम नंबर. ओके, अब ये नंबर 6 बनता कैसे है? व्हेन 1 2 एंड 1 3 गेट मल्टीप्लाइड वी गेट अ नंबर 6. अपने पास 2 का काउंट कितना है 100 फैक्टोरियल में? We have only 97 2s. और अपने पास 3 का काउंट कितना है 100 फैक्टोरियल में? We have 48 3s. तो जब हमारे पास के 3s ही खत्म हो जाएंगे तो अपन 6 कहां से बना पाएंगे? So the maximum number of 6 that can be formed inside 100 factorial are 48. Hence, only 48 6 exist in 100 factorial. Again, I will repeat, जो भी नंबर का लार्जेस्ट पावर निकालना है आपको किसी भी फैक्टोरियल में, वो जरूरी है प्राइम नंबर ही होना चाहिए. Okay, let's look at some questions. Problem number 5. What is the largest power of 81 that can divide 810 factorial? Well, here 81 is not a prime number, so we should not divide 810 with 81. But we know that what is 81? It is 3 to the power of 4. और अपन 3 की लार्जेस्ट पावर 810 फैक्टोरियल में निकाल सकते हैं by successively dividing it like this. So if I divide 810 with 3, I get 270 as quotient. 270 को फिर से मैंने 3 से डिवाइड किया, I got 90, then I got 30, then I got 10, then 3, then 1, then 0 like this. So here we will make the total of all the quotient from 270 onwards. So if I make the total of this 270 plus 90 plus 30 plus 10 plus 3 plus 1 plus 0, this total comes out to be 404. Hence, the largest power of 3 in 810 factorial is 404. So I can write 3 to the power of 4 because 3 to the power of 4 is 81 multiplied by 101 will come here. इसका मतलब ये हुआ कि 81 to the power of 101 is the largest power of 81 in 810 factorial. So the answer is option D. Problem 6. The number 50 factorial will end with how many zeros? How we get 0 at the end? When a number 2 and a number 5 get multiplied, we get 0 at the end. Or even when 5 get multiplied with any even number, we get 0 at the end. So यहाँ पर what we will do, we will find out what is the largest power of 2 in 50 factorial, and we will find out what is the largest power of 5 also in this 50 factorial. So for that we need to successively divide the number 50 with 2. So we get such quotients, and if we take the total of this quotient, that is 25 plus 12 plus 6 plus 3 plus 1 plus 0, the total comes out to be 47. So 2 to the power of 47 is the largest power of 2 in 50 factorial. In a similar way, we will find out the largest power of 5 in 50 factorial by successively dividing it. So we get 10, 2 and 0 like this. If we take the total of this quotient from 10 onwards, the total comes out to be 12. So 5 to the power of 12 is the largest power of 5 inside 50 factorial. Okay. आपको उतने ही zeros मिलेंगे जितने 5s है, because जब 5s ही खत्म हो जाएंगे तो आपको 0 मिलना एंड में बंद हो जाएगा. So when 1, 2 and when 1, 5 get multiplied, you get 0 at the end. The maximum count of 5s is 12. So maximum number of zeros that you will get at the end will be 12. Option D is the correct answer. Hope. So in this video, we have learned the concept of factorization, the concept of power cycle, and largest power of any number in any factorial. Thank you for watching this video.